So when we talk about LC oscillations, we often see that we do not understand the actual mechanism as to what is happening in the LC oscillation and why is this called as oscillation. We know a to and fro motion is known as oscillation, that we are aware of. So say suppose if I have LC, L is for inductor and K is for capacitance. Capacitor and inductor. So if there is an inductor and a capacitor, so it is said that it will oscillate. So why does it oscillate? If we look at this, you can see that first initially, say suppose at one point of time, at time t equals to 0, we have this to be positively charged and this to be negatively charged. So because of this, it will flow. It will flow and this will let it flow. This will let it flow and this charge will come over here, and after that it will change its, because L is equal to di upon dt, that is minus L is equal to minus di upon dt. So di current will change its nature. So after that, the positive charge that was coming over here, after some time it will be reversely polarized because of the sinusoidal function omega t. Now we know omega t varies from -1 to 1, or say +1 to -1, it varies. So after it has changed its nature, it will send current in the opposite direction and charge it again. Again this charge will come and charge it over here. Again this will again charge it back. So this keeps on oscillating, and therefore this particular arrangement is known as LC oscillations or LC oscillator. So now let's look at the mathematical aspect of LC oscillators. Now you know Q by C, because this is a closed loop. This is a closed loop. So if we apply Kirchhoff's law of closed loop, we will see that this is Q by C. This is, if I take over here, from here if I take, this is minus, this is positive. So it is going from minus to positive. So this voltage is my positive. Now over here, this is plus to minus. So this will be my minus L of di upon dt, and since this is a closed loop, so the total potential should be 0. This is 0. Okay. So that we have established. Now Q. Now I was actually equal to dq upon dt, that we know. So when, if Q decreases, say suppose as Q decreases, now I see this is a positive current. So this is a positive current. So we know that if Q decreases, I will also decrease. So now we can establish that d square by q upon dt square plus 1 by LC into q is equal to 0. This is the relation that we have established. This is 1 by LC. Now where did we get? This is I is equal to minus dq upon dt. Now if this is minus, I is equal to minus dq upon dt. Now in this case, what you have to observe is this I is equal to minus dq upon dt. So as the charge decreases, I increases. That is, if this charge keeps on getting decreased, so the current stored over here will keep on increasing until it changes its polarization and sends it back. So this is the definition for, or this is the working for inductors. Now we know this equation is of this form: d square x upon dt square plus omega naught whole square into x is equal to 0. So this particular equation is of this form, where q is a variable. And we know for resonance, we know omega equals to 1 by root over of LC. Therefore q is equal to qm. We know q is equal to qm. This is cos omega t plus phi. So if we talk about dq upon dt, we have qm into omega minus sine omega t plus phi. And if you talk about d square q upon dt square, you will have minus qm into omega square. This is cos omega t plus phi. So far that you have. So now I was actually given by I am sine omega naught t. I is given by sine I naught omega t. Therefore, I am is actually given by omega naught into qm. Omega naught into qm. Now, what is qm? If you look at qm is nothing but q upon cos omega t plus phi. If we discard this, if we discard the value of phi, you will have q upon cos omega t. This is qm. Now if you look I am is equal to dq upon dt. So dq upon dt as we got, this is qm omega sine omega naught t. So if you look over here, this is qm, that is maximum of qm into sine omega naught t. So straight away we can write, by using this relation, what we can write is I am is actually equal to omega naught into qm. Omega naught into qm. That is what we have arrived in a previous relation. I am equals to sine naught omega t dq by dt equals, if I take phi to be 0, minus qm sine omega t. So this omega naught, that is qm sine omega t, is actually equal to, so if I take omega naught common, then this particular value qm sine omega t becomes my qm. So in terms of I am, I can write omega naught plus qm. So far we have arrived at this particular point. Now if you talk about the electrical energy or the potential that is stored inside a capacitor, let's have a talk about the energy stored inside a capacitor. Let's have a look. So the potential energy stored inside a capacitor, or the energy stored inside a capacitor, is 1 by 2. This is qm whole square upon c. This is the energy that is stored, E. Now energy, since there is no current in the circuit, energy in the inductor is 0. In your starting position, where all the charges are in the capacitor and there is no charge in the inductor, then at that point the total energy is stored in the capacitor. This is maximum. So at initial condition, the total energy was this. Therefore, total energy at any point of time will be actually this. Any point of time, total energy U total is half Q m whole square upon C. Therefore, this is your total energy. So now, say suppose after some time, some energy gets stored in the inductor in the form of magnetic energy. Now the charges will flow. And after some time, now this is where we are taking the initial condition. There is no flow of electricity in the circuit. Therefore, there is no energy stored in the inductor. Now after some time, certain energy will be stored in the inductor. Now let's say there is no charge that is over here and all the charge is gone to your inductor. So all the energy stored in the is in the form of a magnetic field. Because if all the charge gets stored over here, this will have your magnetic field, and the total energy we are denoting by UB is actually equal to half L, that is the coefficient, into I square L. This is the total magnetic energy. Now, by the law of conservation of energy, we know these two should be equal. These two definitely should be equal. Only then, only then what we can see is that they will keep on changing from one form of the energy to another form of the energy. So half q m whole square upon c is equal to half l I m whole square. So this half and this half gets cancelled. So now what you have is q m upon whole square by c is equal to l I square m. So this is the relation, or this is the oscillating relation that we can derive from. Further, if we calculate, now if we solve this, we have in a previous equation, what we had is omega naught is equal to k by m. Now, if we compare this with the spring constant, like we use for the oscillations of the spring, we will have force is equal to mass into acceleration. Now this is actually equal to m dv upon dt. Now what is this equal to? dv upon dt is actually equal to m dx square into dt square. dv into dt is equal to dx square into dt square. So by using this understanding, what we can do is, look over here. We had already in our previous slide had derived a differential equation of 2 degrees. So by using this, what we can say is that this is F. So the total electromotive force for that particular circuit is minus L di upon dt, which is equal to minus L. What is di upon dt? Is nothing but dq square upon dt square. This was what we had arrived. And now comparing this to, we have the angular frequency omega is given by 1 by root over of LC. This is 1 by root over of LC, and if you compare this with omega naught is root over of Kc, so this is a conservative force. So similarly we can say that it is also oscillating, and the oscillating frequency is given by 1 by root over of LC. So this is the combination that we can make.